Welcome to lesson 8.2. Today we're going to continue talking about exponents, but now we're going to talk about properties when we have quotients involved. Quotients mean division. Let's zoom in on this first key concept. If we have two terms with the same base, for example, 4 to the 7th divided by 4 squared, we can subtract those exponents by moving the 2 up, and we end with 4 to the 5th. So it's top exponent minus bottom when we end up on top. Top minus bottom. Let's slide down and take a look at example 1. We have a handful of great examples here. Let's look at letter A. A to the 10th divided by A to the 4th. We have to do 10 minus 4. We get A to the 6th. So top exponent minus the bottom. That's how we simplify that situation. This next example, we have a 9 and a 3 as our exponents. We subtract them, we get a 6. Negative 3 to the 6th power. This next example, there's 2 steps we could do. The first would be to deal with this top of what I highlighted in red. 5 to the 4th times 5 to the 8th will give us this 12 for an exponent because we add those together. But now we can deal with the 12 and the 7 as division, so we subtract. So when we see division, subtract. 12 minus 7 is 5. Letter D. We have these 2 fractions. We can multiply fractions together by remembering that there's actually a 1 underneath this fraction. So now we get x to the 6th divided by x to the 4th. If we do our subtraction of 6 minus 4, we get 2. So that's the pattern, is subtracting. 11 minus 5 will give you 6. 9 minus 2, in example F, will give you 7. Example G, back to having a couple steps to this problem. 9 to the 4th times 9 to the 3rd. We have to add those exponents. Then the next step is we can subtract 7 and 2 to get 5. Example H, we have to multiply those fractions together to get this one in red. A to the 5th, or A to the 8th divided by A to the 5th. 8 minus 5 is 3. So this is called the quotient of powers property. You can see up in your key concept. Term with the same base divided by another term with the same base. We subtract exponents. So let's take a look at the second example that you might see, or what you might call the second situation. Oh, I apologize. For some reason it's not showing up on what I would call the algebra and the example section. So what we might see here is something like this. We're going to start out with what I'm going to highlight in red. A over b to the 4th power. What that really means is 4 a's divided by 4 b's that are multiplied together. And we end up with this situation in blue where they each get the exponent of 4. So if we see an exponent on the outside, we share it with both. So let's take a look at example A. X over y to the 3rd power. That 3 gets shared with both terms. Then you're done. This 2 gets shared with both terms. We could go one step further to call negative 7 squared 49. But then x squared just stays as x squared. Let's look at example D. We have this a over b squared. The 2 gets shared with both, and then you're done. Example E. The 3 gets shared with the negative 5 and the y. Negative 5 to the third is actually negative 125. The y gets the 3, and then you're done.